So now we're going to represent equations with tables and graphs. Frankenstein joins a health club. There's a $50 sign-up fee and $30 for each month he is a member. So the very first thing we're going to do, A, is to name the quantities that change in the problem and the quantities that remain constant. So what's changing is, well, how many months he's a member, and the total amount he spends at the health club. The quantities that remain constant are the $50 sign-up fee and how much he pays each month don't change or remain constant. Now, which quantity is independent and which one is dependent? Well, for this we're going back to the quantities that change. And something that I've always told the students is on a graph, the vertical is the y-axis, the horizontal is the x-axis, and 95% of the time, if time is involved, it is on the x, and the x is the independent. And 95% of the time, if money is involved, it is the y, which is the dependent. In this case, we have both time and money, and yes, those are the independent and dependent. So the number of months is going to be the independent, and the amount of money spent, total amount, is going to be the dependent, because the amount of money he spends depends on how long he's a member. He can stop at any time, but the amount of money he spends will depend on how long he remains a member. Part B wants me to create a table of values to represent the total cost if Frank is a member for 1 month or 2 months, or spends $170, $200, or $260. So for 1 month, we know it's going to be that $50 charge plus $30 for 1 month. So that's 50 plus 30. That would be $80 just for the first month. For 2 months, that would be the original $50, but now it's going to be $30 times 2 months. So 50 plus 60. So that's $110. For 170, well, now what we need to do is do 170 minus that $50 and then divide it by 30. So that's 120 divided by 30. So 4 months. If he has spent $170 total, he has been a member for 4 months. For 200, we subtract the 50, divide it by 30, and get 5 months. For 260, the same thing. So if he spent 260, he's been a member for 7 months. Part C wants you to create a graph. Now, I usually have the students work on a 10 by 10 graph, so even though it's not square, this has 10 marks in either direction. So now we need to take our table. As a quick reference, I'll just put that quick table over here to the side. We need to consider, again, this is our x-axis right here, or our x values, and these are our y values. So with 10 along the bottom, it's easy to count by ones. So the first mark will be 1, then 2, 3, 4, 5, 6, 7, 8. And I just mark every other one, mostly out of laziness, and sometimes my numbers run together. But now I have to figure out what I'm going to count by on the y-axis. I see I have to get to 260. So if I divide 260 by 10, that gives me 26. Now I really don't want to count by 26. 25 would have been fine, but if I do 25, I won't get to my top number there. So probably I'm going to count by 30s. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. And I also need to label these with words. Now I do my best to plot the points. 1 and 80. I know 80 is between 60 and 90, so right about here. 2 and 110 is just below 120. 4 and 170 is just below 180. 5, 200 is just below the 210. And 7, 260 is just below the 270. And as you can see, they pretty well line up. I don't have a straight edge, so if I freehand it. But I can see, well, we're going to answer that question here in a minute. Part D wants us to describe the relationship between the two quantities and define the variables. Well, when it wants us to describe the relationship between the two quantities, it's saying as x increases, what happens to y? And in our case, the x is the number of months. So as the number of months increases, what happens to the y, or in this case, the amount of money? Well, the total cost increases as well. And defining our variables is really easy because we've already graphed it. We know that the x is the number of months, and the y is the total cost. Next, you may be asked to use the graph to come up with a certain number. Like it might say, so after 6 months, how much did Frank spend? So that's where you use the 6, and you go up as straight as you can to the graph, and then follow it over the best you can. And it looks like it would be somewhere between 210 and 240. So, 220 is a good guess, 230. It doesn't have to be exact. So at 6 months, we would expect him to have paid 200, and if that looks exactly in between, you can go with, it looks a little closer to the 240, so I'm going to go with $230. Now this may not be exact, but it's saying using your graph, so it depends on how well you make your graph. It might also ask you if he has spent, let's say, $150. How long has he been a member? Well, it looks like about 3 months, just according to the way I've drawn my graph. So if he spent $150, he must have been a member for, did I say? Yeah, 3 months. And again, these don't have to be exact, but just using your graph, so that's why it's important to make as clear a graph as possible. Next, we need to write an equation. So our equation is going to be what the total cost equals. So the total cost is going to equal the initial amount, $50, plus what we're paying, or what Frank is paying per month. So 30x. The last question is going to ask us, using the equation, the graph, and the table, explain if this situation represents a proportional relationship. Well, we can get that just from the graph. Remember, to be a proportional relationship, you have to be linear, which this one is, but you also have to go through the origin 0, 0. So we could tell just from the graph that this is not a proportional relationship. From the table, we can't really see it because we'd have to have what 0 is, and 0 is not on our table. From our graph, we can see it's not proportional because of this right here. All of our proportional equations were y equals kx. And we have that part of it, but we have this added amount over here, which makes it not pass through the origin. So this would not be a proportional relationship. Now we could go back on the table and subtract the 30 and get the 0.50, so I really should mention that we can tell from the table the graph and the equation if it's proportional.